I want to talk today about writing net ionic equations. What we're going to do is we're going to balance and write the net ionic equation for the reaction between sodium phosphate and magnesium chloride. And we're going to follow a number of steps that will help us and guide us through the process. Most of the time when we're balancing net ionic equations, we're talking about looking at double displacement reactions. So the first step that we're going to do is we're going to swap the anions. So the phosphate is going to go where the chloride was, and the chloride is going to go where the phosphate was. When we do that, we get NaCl and MgPO4. Now it's very important at this point that you don't try to balance the chemical equation. A lot of people will make the mistake that they'll see, oh, I have 3 sodiums on this side, so I have to have 3 sodiums on the other side. So what they will write is this, Na3Cl2. Now I have the right number of sodiums and chlorides, but this is not a correct chemical structure or chemical formula. Do not do this. Do not try to get ahead of yourself. Do not try to balance at this point. All we are doing is trying to get the sort of skeletal framework of the compounds that we're going to have. We'll worry about balancing later. So the next thing that we're going to do is we're going to write correct chemical structures. Now, I know from what I've learned previously that sodium is most often +1 and chlorine is most often -1, so sodium chloride is a correct chemical structure. On the other hand, I know that magnesium is +2, and from what I remembered of my polyatomic ions, PO4 is -3, so MgPO4 is not a correct chemical structure, so we have to fix that. So I changed to Mg3PO42. Now both of my products are written as correct chemical structures or chemical formulas. Now I go and balance my formula so I have the right number of atoms on each side. With a little trial and error, I was able to find that I have 2 sodium phosphates, 3 magnesium chlorides, 6 sodium chlorides, and 2 magnesium phosphates in my final balanced structure. Next, I have to list everything in the correct state of matter. And how I do that is I look at a solubility table. There are many different kinds of solubility tables you can use. This is an example of one of them. And it tells me the different groups, the different statements regarding their solubility, and any exceptions. So for instance, in this table, it tells me group 1, ammonium and nitrate are always soluble. So sodium is in group 1, so I know the sodium chloride is going to be soluble. For the phosphate, it tells me that most phosphates are insoluble. So I can use this data, this information, to decide the states of matter of my compounds. Since my sodium chloride is soluble, it's going to be aqueous, but since my magnesium phosphate is insoluble, it's going to be a solid. Now I'm going to write my full ionic equation. When I write my full ionic equation, I break up all of my aqueous compounds into ions. My solids and my liquids stay together as a whole. So my full ionic equation looks like this. 2 sodium phosphates, but I have 3 sodiums in each of them. So that gives me 6 sodium ions and 2 phosphates and so on. I've broken up everything on the left side into the ions. On the right side, since my sodium chloride is aqueous, I have 6 sodium ions and 6 chloride ions. But my magnesium phosphate is a solid, so it stays as a solid. And I didn't quite give myself enough room here between my chloride and my phosphate. Just let me fix that. Oh, come on, it thinks I'm doing a formula. Okay, so now we have everything in the proper state. My magnesium phosphate is a solid, and the sodium and the chloride are ions. Now I want to warn you about some mistakes that people will make sometimes. In particular, people will see Cl2 up here, and they will write Cl2 -1. It's not Cl2 -1. This means 2 Cls. It is Cl minus, not Cl2 -1. Please do not do this. People will do a similar thing for H2SO4. They will write H2 plus instead of 2H plus. Again, don't do this. What we're going to do next is we're going to cross out the common ions, the ions that are the same on both sides. So we have 6 sodiums on the left. I'm going to make a line through that. 6 on the right. We have 6 chlorines on the left, 6 chlorines on the right. So we've crossed out the things that are the same on both sides. So now we're going to write what's left. So what's left is 3 magnesium plus 2s and 2 phosphate minus 3s on the left, and those are both aqueous, and magnesium phosphate on the right. So this is my net ionic equation. 3 magnesium plus 2 aqueous plus 2 phosphate negative aqueous, negative 3 aqueous gives me magnesium phosphate.